Throughout history, we've turned to science for solutions to all sorts of problems, big and small. For scientists, the satisfaction of understanding nature is what keeps them rooted to their lab bench or motivates them to work in sweltering jungles or a frozen ice canyon. But it's much more than a personal triumph. Scientific research has a direct and immediate impact on the very future of our planet, as well as on its many inhabitants.
There is, on the one hand, this excitement about seeing new things, but at the same time, there are pressures of real life. So researchers are, and should be, people too.
Scientific research is built on a foundation of trust. Scientists trust that the research results are valid, and society trusts that the research makes an honest attempt to describe the world accurately and without bias.
Mentors are individuals who have experience and expertise that they're willing to share. The mentors are really important because there's so much more to know about science than scientific principles and concepts and laboratory techniques or research strategies.
Many researchers specifically point to the influence of their advisors and their mentors on their own successes, but sometimes those relationships are not free of conflict.
The graduate student experience is a lot like an apprenticeship, so that relationship with an advisor is incredibly important.
But I've definitely been around bad advisors, and it's unfortunate because you never know if someone's going to be bad until you work with them, and by the time you figure it out, you're kind of, you're on your way, and you can't really just quit.
It's really important for trainees to communicate with their advisors and with the thesis committee members as other potential mentors that can give them reliable input.
It's important to remember that scientific research is susceptible to error. At the frontiers of knowledge, experimental techniques are pushed to the limit, and sometimes the signal can be difficult to separate from the noise.
One of the major risks that we have and that we recognize is the challenge to, in fact, not be swept up with the enthusiasm of the particular theory of the moment.
Researchers are human. That's why the standards of research are designed to minimize the possibility of mistakes, and when mistakes do occur, to correct them through the open sharing of information.
Peer review is, on the one hand, the way in which the scientific community has really identified a set of colleagues that are normally anonymous and are put in a position to evaluate the internal consistency of the data. So when scientists do research that depends on the work of other people, and that work that they're building on is actually made of sand, then it's extremely problematic, and it really undermines within the community something that's extremely important, which is reputation.
Some people view publishing a correction as being somehow a disgrace, and I personally don't see it that way.
The scientific community is forgiving. If you find an honest mistake, you can make a correction, and you can also find that your model is not as good as it can be and you can improve on it. If you are found to have covered up something in order to protect yourself, then that is an entirely different situation.
Young researchers building on the work of others only have a fairly finite period of time, and if they get off on the wrong direction based upon a misrepresentation of the research findings, then that really undermines their whole career.
Research results are generally made public when they appear in published papers, but sometimes figuring out who gets credit can be difficult.
Authorship is probably the most problematic area in learning how to survive and function in the research community.
I think it's a huge issue, authorship. I think people even notice when you are the second author.
Having an authorship on a paper means a lot. and one paper can make a very big difference in your career.
Unfortunately, most people judge your scientific merit based on how many first author papers you have.
The standards of science extend beyond responsibilities that are internal to the scientific community.
The core values on which science is built, the ethical values of science, are in some respects not different than the ethical values of any profession of society as a whole. But it is not the case that everything we need to know we learn in kindergarten. The basic principles on which science are built are honesty and integrity and fairness and respect.
These values have helped produce a scientific enterprise of unparalleled usefulness, productivity, and creativity. So long as these values are honored, science and the society it serves will prosper.